Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers distance, speed, time. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 2. Hector can run 400 meters in 66 seconds. Use this information tool to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance traveled, and this, which is time taken. And I know a relationship between distance, speed and time. Do you? It's a handy little little triangle, distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those three quantities. Now we want speed, which is down here, look, and that tells me that it's the other two divided by each other. So speed, or average speed, is distance traveled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance traveled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still is the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's giving me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. Question 5 says the direct route between two airports A and B is 450 kilometers. An aircraft leaves A at 09:15 and it arrives at B at 10:55. Work out the average speed of the aircraft. Assume that the aircraft travelled the direct route. So we can remember about this using the DST triangle, distance, speed, time. Here we've been given the distance. It's 450 kilometers. We've been given the time. It's the difference between 10:55 and 9:15, which is a time span of 1 hour and 40 minutes. Now, it's a bit difficult to calculate with minutes and hours. So I'm going to rewrite that 40 minutes as a fraction. So that's 1 2/3 of an hour, or that's another way of saying 5/3 of an hour. So I'm going to use 5/3 for my time. And then obviously it's speed that we're trying to find. Then using the triangle, we know that speed is equal to distance divided by time. So the distance we said was 450 and the time was 5/3. Well, dividing through by a fraction is the same as flipping that fraction over and times, isn't it? So that's the same as that. So 5s into 450 go 90 times, and then times 3 is what, 270 kilometers per hour? Okay, and in part B it says in fact the aircraft did not travel the direct route. So how does this affect the average speed? Okay, well, if he hasn't gone the direct route, it means the distance is going to increase. So this value here will be more, the time will be the same. So if I increase the distance in this calculation, then I am going to increase the speed as well, aren't I? So it's going to increase. So how does this affect the average speed? The average speed is going to be faster than this. And the reason is it's travelled a greater distance in the same time. Question 6. Beth drives 200 miles in 4 hours. She drives the first 18 miles at an average speed of 36 miles per hour. Work out the average speed of the rest of the journey. So we've got a question here involving distance, speed and time. You can remember how these are related using this triangle. It's the DST triangle. D at the top, S and then T. They're alphabetically listed, aren't they? D, then S and T. And this tells you how those three things are related to each other. Okay, now we're going to look at this journey in 3 different ways. First off, we're going to look at the whole journey, so the total journey. Now the total journey, what is D, what is S, what is T? Well, we've got the distance, which is 200 miles. We don't have the speed, but we have the time, which is 4 hours. But we can find S then using the other two. So we just cross off, kind of stick your finger on top of the one you're trying to find, in this case S. And then the triangle tells you what to do with the other two. So average speed, oops, let's write in blue. Average speed is distance travelled divided by time taken. In this case, it's going to be 200 divided by 4, which is 50, isn't it? 50 miles per hour. Okay, so that's the average speed for the whole journey. Right, so does that help us? What does the next part says? It says she drives the first 18 miles at an average speed of 36. So I'm going to write this. This is the stage 1 then of the journey. There's 2-stage journey, isn't there? The first section, we know D and we know S, but we don't know T. So let's find T. Let's see if that helps. So we know that the distance is 18. We know that the speed is 36. So what we want to find is time. So again, going back to the DST triangle, if you cover up T, you can see that time is going to be distance divided by speed. Okay, which is going to be 18 divided by 36, which looks like a half to me, 0.5. So what's the units of that then? So this is time in hours then, isn't it? So 0.5 hours, that's half an hour or 30 minutes. Okay, I'm just going to leave it in hours for now. Okay, so then stage 2 of the journey, what do we know about this stage? Do we know anything about it? We know the total distance travelled was 200, and we know that distance travelled in stage 1 was 18. So the distance travelled in stage 2 then is going to be 200 minus 18, then, isn't it? That's going to be 182 miles. Do we know the speed? No, that's what we're trying to find. Do we know the time? Well, again, we know that the time for the whole journey was 4 hours. We've just calculated the time for stage 1 to be half an hour. So that leaves us with 4 subtract half an hour. That leaves us with 3.5 hours then, doesn't it? For the second stage of the journey. Okay, and then we want to find the average speed of this part of the journey. So again, from the triangle, cover up S, tells me that speed equals distance over time, which is now 182 divided by 3.5. Okay, time to reach for a calculator, I think. So 182 divided by 3.5 comes out to be 52. Okay, so that's 52 miles per hour then. Rob is going to drive 130 miles from Hull to Liverpool. There are roadworks for 25 miles of the journey, only 25, and he assumes his average speed will be 50 miles an hour where there are roadworks and 70 miles an hour for the rest of the journey. Using his assumptions, work out the journey time. So I'm going to break this journey up into its 2 different sections, the part where there are roadworks and the part where there are not roadworks. So during roadworks, then distance is 25 and speed equals 50. Okay, and then we know we've got our little triangle, DST triangle for distance, speed and time. So average distance is speed times time, and speed is distance divided by time. So time is distance divided by speed. So time taken equals distance divided by speed, which is 25 divided by 50, which is 0.5. Now speed was in miles per hour, and that was in miles, so this is 0.5 hours or 30 minutes. Okay, so then outside of the roadworks, during other times, then the total distance travelled will be the remainder of the journey. So there are 130 miles altogether, and if 25 miles were roadworks, then 130 minus 25 is going to be the non-roadworks. So 105 miles. And we're assuming that the speed for this part of the journey is 70. So speed equals 70. Now again, time taken is going to be distance over speed, which is 105 divided by 70. Now trying to cancel this down, 105 is actually in the 7 times table, so we can divide the top and bottom by 7. 7 goes into 105 15 times, so that's 15 over 10, and then that's 1.5 then, isn't it? So it takes in 1.5 hours. So then the total journey time is going to be those 2 times added together, equals my 0.5 plus my 1.5, giving a total journey time of 2 hours. 2 hours. Okay, done. Right, in part B, we're told that Rob's assumptions about his average speeds are too high. How does this affect his journey time? Well, let's have a think about it. If his speeds were too high, then actually he's going to be going at a slightly slower speed. So this value here will be less than it was before. So we'll be dividing a number by a smaller number, which will give me a bigger amount of time. It'll give me a bigger answer. And the same is true for the second part of the journey. Again, if this one here is smaller than we thought, then the outcome is going to be larger than we thought. So the times will increase. So if the speeds decrease, then the times will increase. So if assumptions for speed are high, then the journey will take longer. Question 9. Tom and Adil are the 2 runners in a 200-meter race. Tom completes the race in 24 seconds. Adil completes the race at an average speed of 28.8 kilometers per hour. Who wins the race? You must show your working. Okay, well, I guess the person who wins the race is the person who runs it in the shortest amount of time. Now, Tom completes the race in 24 seconds, and we know it's a 200-meter race. Adil completes the race at an average speed of 28.8 kilometers per hour, so we should be able to work out the time it takes because we know the distance that he ran. It was a 200-meter race, and we know the speed he ran it at. Okay, so the only thing we don't know is time there, isn't it? So using the DST triangle, distance, speed, time. If you hadn't noticed, they're alphabetical from top to bottom, so it should be easy for you to remember which way around it goes. And then see if we can identify what D is, what S is, what T is. Well, the distance is the distance travelled, isn't it? Which in this case is 200 meters. It's the value that we had up there. The speed is 28.8 kilometers per hour, which is we got from there. And so the only thing that we don't know then is time, and that is the thing we're trying to find, isn't it? How long it took him to run the race. So covering up T, that tells me that time is distance divided by speed. So time equals distance divided by speed. Now the distance was 200. A slight issue here in that we got different units, haven't we? Okay, so in order to sub in meters and kilometers, probably best idea to convert that into kilometers first before we go any further. So I'm going to say, well, 200 meters, that's the same thing as how many kilometers then? So there is 1,000 meters in a kilometer. So 200 meters is going to be 0.2 of a kilometer then, isn't it? Okay, so I'm going to rewrite that one as 0.2. So then my units all match. Okay, so I've got 0.2 kilometers. So 0.2 divided by 28.8. What's that then? That's a very short time in hours. 0.2 divided by 28.8. It comes out to be 144th or 6.94. Looks like it's reoccurring there. Might just write that as 1 over 144 for now. So that's in hours, isn't it? Okay, I don't want it in hours, I want it in seconds, so I can compare it with Tom's time. So to convert that into seconds, I'm going to have to multiply by 60. That will tell me the number of minutes, and times another 60 to give me the number of seconds. So taking my answer and multiplying it by 60 and then multiplying it by another 60, that is going to give me 25 seconds. Okay, so now I can see then I've got 25 seconds for, this was Adil, wasn't it? We're doing Adil's race at the moment. We know that Adil then is 25, and we know that Tom completed it in 24 seconds then. So who's faster? It's Tom by a second, isn't it? So Tom fastest. Question 10. The diagram shows 3 routes A, B and C between 2 towns X and Y. The distance and average speed for each route is shown. So we've got 3 different routes from X to Y. All have got different distances and different speeds. So which of the 3 routes takes the longest amount of time? Assume average speed given. You must show your method. Okay, so let's work these out then. So you should remember the relationship between distance, speed and time. I tend to remember them as a DST triangle like that, so I can cover up one bit to work out the others. So covering up the T in the triangle shows me that time is equal to distance divided by speed. So I can now work out time taken for each of these. So time equals distance, 25, divided by speed, 50. 25 divided by 50 is a half. So that's 0.5, and the units is going to be hours, because I've got miles and miles per hour. For route B, time taken is going to be the distance travelled, which is 20 divided by the speed, which is 30, which is 2/3 of an hour. 2/3 of an hour, 40 minutes, I suppose. This one I could write as 30 minutes. Might be easier to compare that way. And then route C, 30 miles at 40 miles an hour. Then time taken is going to be my distance divided by my speed, which is 3/4, and 3/4 of an hour is 45 minutes. So which one took the longest time? It's going to be route A. Again, it's not essential that you show your method in this space here, and sometimes it's easier to do the work on the diagram. However, I've been a bit naughty here and gone over the edges, so I should probably write that answer there, because they scan these in these days. So if you do write over the edge, the examiner's not going to see it. Okay, so you can write on the diagram like that, but don't go over the lines. Part B says John and Matt take the same time to travel from X to Y. John travels along route B at 10 miles an hour faster than the average speed, and Matt travels along route C. Does Matt travel faster or slower than the average speed for route C, and by how much? You must show your working. Okay, so John's going down route B at 10 miles an hour faster than he should be, or then that's on average, so he's going to be, so John's going this way, isn't he? This is John's route, and he's going to be going at 40 miles per hour because he's going to go 10 miles an hour faster. So he's doing 20 miles at 40 miles per hour. And we know that Matt is going along route C, and we want to know whether or not he's going faster or slower. So Matt is going this way. Okay, so if we work out how fast it takes John, we can then work backwards and work out how fast Matt was going. Okay, so let's do that. So John is going at 20 miles at 40 miles an hour. So John, time taken is going to be distance again divided by speed, which in this case was 20 over 40, so it's going to take him 0.5 hours. Okay, so let's then work backwards, because we don't know how fast Matt is going, but we do know he's traveling for 30 miles. So then Matt, then speed is going to be distance divided by time. So the distance was 30, and the time is going to be the same as John's, because they arrive at the same time, so it's going to be 0.5, which means he's got to be travelling at 60 miles per hour. So the route speed average was 40 miles an hour, so he's going significantly faster than that. So Matt is going faster by 20 miles per hour. Question 11. A, B, C and D are junctions on a motorway. Now the distance CD is equal to 3 times the distance of AB. So this distance up here is going to be 3 times as big as this one. And the distance of BC, the bit in the middle, that we're told is 25 miles. Okay, so this one here is 25. If we say that this one here is X, then this one is going to be 3 times bigger. So then that would be 3x. Okay, so I've got x, 25, and 3x. Salma drives from A to C. Okay, so she's going from here up to here. Okay, she drives for 30 minutes at an average speed of 62 miles per hour. Work out the distance AD. Okay, so once we know, basically what we're going to have to do then is we're going to use this bit of the problem to find the distance from A to C, and then we can use that to find the distance from A to B, and once we know that, we can find the distance of C to D, and once we know that, we know everything. So it's going to be like a number of steps along the way here, isn't it? Okay, so let's start with, I think we're going to have to start with this. She drives 30 minutes, an average speed of 62 miles an hour business. And I'm going to be using the DST triangle. Distance, speed, time. Distance, speed, time. So DST is alphabetical if you forget about what order they go in. So D first, then S, then T, as they are in the alphabet. And I want to work out what D is, S is, and T is. I'll know 2 of them, and I can use the 2 to find the third one. Right, so she drives for 30 minutes at an average speed of 62 miles an hour. So we know speed, it's 62 miles per hour. And we know time. Now time is in minutes and speed is in miles per hour. So I'd like to convert that 30 minutes into hours so it matches the units with the miles per hour. So rather than writing the speed of a time of 30 minutes, I'm going to rewrite that in hours. So 30 minutes is half an hour, or 0.5 hours, isn't it? Okay, so time is 0.5 hours and speed is 62. So from that, we should be able to work out D, the distance. Okay, so we're going to cover up the thing that we don't know, it's the D. And then that tells us that the distance is equal to the speed times the time. Okay, so distance equals speed times by time. which in this case is 62 miles per hour times by 0.5. So basically we're going to halve 62, aren't we? And that is going to give us 31. What's the units? Speed was in miles per hour, time was in hours. Multiply it together, you're going to get miles. So that is 31 miles. Okay, so that whole pink bit up there is 31 miles. So if the green bit is 25, then that little yellow bit at the beginning must be 25 taken away from 31. So my little x that I wrote down there earlier, the little x down there is going to be 31 take away the 25, then that's going to be 6. Okay, so this is equal to 6 then. So 3x means it's going to be 3 lots of 6 there, and that's going to be 18 then, isn't it? So I've got a 6 mile section, a 25 mile section, and an 18 mile section. So what is the distance of AD? Then AD is going to be those 3 amounts added together then, isn't it? It's going to be the 6 for AB plus the 25 from BC plus the 18 from CD. And that adds up to, what's that, 31, 41, 49. That's 49 miles. Okay, that's my answer. Question 12. The distance by road from Newport to London is 140 miles. Tom travels by coach from Newport to London. The coach leaves Newport at 1:30 p.m. He assumes that the coach will travel at an average speed of 50 miles per hour. Use his assumption to work out the arrival time in London. Okay, we were just talking about the DST triangle, so let's just draw that out now. Distance, speed, time. Right, so what have I got here? I've got the distance. That is 140. Time is what I need to work out, isn't it? I need to work out the time he arrives in London, and I know the average speed is 50. Okay, that's in miles and that's in miles per hour. Okay, so the one I want to find is T. So kind of putting your thumb on top of the T, it tells you what to do with the other two. Time is equal to distance divided by speed. So time taken is equal to distance traveled divided by average speed, which is 140 miles divided by 50 miles per hour, which gives me 140 divided by 50. It's giving me 2.8. Now that's a decimal number. So it's 2 hours and 0.8 of an hour. So how many minutes is 0.8 of an hour? Well, there are 60 minutes in an hour. So 0.8 of an hour, 0.8 times 60 is going to give me 48 minutes. So that is equals to 2 hours and 48 minutes. Okay, so if we remember, we left Newport at 1:30 p.m. so if we're traveling for 2 hours and 48 minutes, so I'm gonna have to add that time on then, aren't I then? So 1:30, 2:30, 3:30. 30 minutes takes me up to 4 o'clock, and then I've got another 18 minutes after that to add on. So that's 4:18, isn't it? So 4.18 p.m. In part B, we're told that in fact the coach has a lower average speed than this, so it's not going as fast as 50 miles an hour. So this speed here then is going to be less than it used to be. Okay, so if you're going to divide through by a smaller number, then this number is going to get bigger, isn't it? So if you divide by something by a smaller number, you're going to get a bigger result. So that means the time is going to increase. So, and if the time is going to increase, then I'm going to be arriving later than the time that I had before. So in fact, the coach is going to arrive later. It will arrive later than planned. Question 8a. Train A travels 120 kilometers at a constant speed of 80 kilometers per hour. Train B travels 120 kilometers at a constant speed of 50 kilometers per hour. How many more minutes does train B take to travel to 120 kilometers than train A? Okay, so I'm going to use a distance, speed, time triangle here. DST. So this is going to be train A. Let's do train A first. So train A, distance, speed, time. Distance, speed, time. What's what? Distance is 120 kilometers, isn't it? Okay, that's there. And then I know speed. Speed is 80. Okay, so speed is 80 kilometers per hour. So what we want then is time, isn't it? That's the one we're trying to find. So cover up T, and that tells me, the triangle tells me what to do with the other two. So it's going to be time equals distance divided by speed, okay, which is distance 120 divided by speed, which is 80. What's that? That is 120 divided by 80. That's 1.5, isn't it? 1.5. That's going to be in hours, isn't it? 1.5 hours. That's 1.5 hours. That is 90 minutes, isn't it? Okay. Remember, the answer needs to be in minutes. So yeah, I'm going to convert into minutes. Let's now look on at train B. Do the same thing. Train B. Same thing. Distance, speed, time triangle. DST. Distance is still 120 kilometers. Speed this time has been reduced, isn't it? It's now 50. So that's 50 kilometers per hour. And we're still finding time. So it's still going to be time is equal to distance divided by speed. Which this time is 120 over 50. What's that then? 120 divided by 50. That comes out to be 2.4. Okay, now what is that in minutes? Well, if I press the little circle dash double dash button, can you see that converts in 2 hours and 24 minutes? Okay, so 2 hours and 24 minutes, that is 60, 60 and 24, 120, 144 minutes, isn't it? Could just times it by 60, I suppose. That would have been easier. So anyway, I've got 90 minutes and 144 minutes. So how many more minutes does train B take? Difference is going to be 144 minus 90. Just get into the habit of writing down anything that you type into your calculator. It's good practice. If you make a mistake with your calculator, you're still going to get the marks for method. So difference is 54 minutes. And that's my answer then, isn't it? Part B says, train C has a speed of x kilometers per hour. Write an algebraic expression for train C's speed in meters per second. Okay. So I've got in kilometers per hour, it's equal to x, isn't it? Okay, now if I want to change to meters per hour, I would have to multiply by 1,000, wouldn't I? So that is equal to 1,000 x meters per hour. Okay, and then if I want to convert it into meters per minute, then I'm going to have to divide by 60, aren't I? Because there are 60 minutes in an hour. And it's obviously going to be doing fewer meters in a minute compared to in an hour. So I'm going to divide by 60. And then to go from meters per minute to meters per second, I'm going to divide by another 60, aren't I? So it's actually going to be 1000x over 60 times 60. Okay, so what's that? That's 1000 over 360. So that's 1000 over 360x. I could cancel that with that. Can I cancel that down any further? Just type it into the calculator. It will cancel it down for me. That comes out to be 25/9. So I'm just going to write that as 25x/9. That's my final answer. Question 12a. Aaron ran a distance of 5 kilometers at an average speed of 2.2 meters per second. How long did Aaron run for? Give your answer in minutes and seconds to the nearest second. Okay, so there's a handy triangle to remember. Distance, speed, time problems, which way around it all goes. So DST, distance, speed, time, and they are alphabetical. So D before S before T. Okay, so this little handy triangle, if you know any two of them, you can find the third one then, can't you? So here I've been given the distance, and that is 5 kilometers, and I've been given the speed, which is 2.2 meters per second, and the time is what I want to find. Okay, so time, covering up the thing I want to find, time tells me what to do with the other two, distance divided by speed. So I'm going to be using time equals distance divided by speed. Okay, but just take care here because we've got different units going on here, haven't we? So I've got the distance measured in kilometers, and I've got the speed measured in meters per second. Okay, I think it's going to be easier to convert the distance into meters first. So I'm going to say that 5 kilometers is 5,000 meters first, and then we can sub into our formula for time. So time is distance, 5,000 meters, divided by speed, which is 2.2. Okay, trusty calculator. What is 5,000 divided by 2.2? Apparently that's 2,272.72. Just going to round off as 73 actually. That's 4 significant figures, plenty. And anyway, it's the nearest second. So that is in seconds. Now it says give your answer in minutes and seconds, and I've got seconds. So how many minutes in 2,273? 2273 divided by 60. That is, I'm actually going to put it as a mixed number. So press the shift and then the S to D. I can see that's 37 and 53/60ths, which is a bit handier to write down. So that's 37 minutes and 53 seconds. Okay. So 37:53. Part B says Claudine cycled a distance of 53 kilometers in 2.7 hours. The distance is measured correct to the nearest kilometer. The time is given correct to 1 decimal place. Calculate the lower and upper bound of her average speed, giving your answer correct to 2 decimal places. Okay. Now my advice on these upper and lower bound questions is to draw a number line for each of your quantities. Mark on the value you've been given. So for the distance, that's 53 kilometers. Now that's been given to the nearest kilometer. Okay, so the next one up on the scale to the nearest kilometer is 54, and the one below it would be 52. Now, which numbers round to 53? It's going to be the ones that are halfway between 52 and 53 or nearer, or halfway between 53 and 54 or nearer. So the values between there and there, they're the ones that are round to 53. So where are the bounds? Well, halfway between 52 and 53 is 52.5. And halfway between 53 and 54 is 53.5. Okay, so that's going to be the lower and upper bound for the distance. Going to do the same thing for the time. We've been given 2.7 hours to the nearest what? Time is given correct to 1 decimal place. So 1 decimal place above 2.7 would be 2.8, and 1 decimal place below 2.7 would be 2.6. Halfway between then is going to round to 2.7. So this area here, what are the boundaries? Halfway between 2.6 and 2.7 is 2.65. Halfway between 2.7 and 2.8 is 2.75. Okay, so once we've worked out what all the upper and lower bounds are for the distance and the time, we're going to work out the average speed, and we're going to pick the upper or lower bounds of either of those in a way that's going to deliver me the upper and lower bounds for the average speed. So remember our DST triangle, distance, speed, time. This time we're after speed, aren't we? So let's cover up speed, and that tells me that speed equals distance divided by time. So let's write that down. Speed equals distance divided by time. Okay, right, for the lower bound, how am I going to get the smallest possible speed from those various values that I've got on here? Okay, so for the lower bound for the speed, I'm going to get the smallest speed if the distance is the smallest distance that was travelled. So I'm going to use the lower bound for the distance. It's going to make my numerator the smallest possible value so that I get the smallest possible answer. And then divide by, but I'm going to divide by the upper bound for the time, because the smallest possible speed will be given by the largest possible divisor. So dividing by 2.75 is going to give a smaller answer than dividing by 2.65. Okay, so what's that then? 52.5 divided by 2.75. That comes out to be 19.090909. I need to round that off to 2 decimal places. So that is going to be 19.09 then, isn't it? 19.09. What about the upper bound of the speed? Okay, now again, it's going to be distance divided by time, but this time I want the biggest possible combo. So I'm going to take the biggest possible distance, which is 53.5, and I'm going to divide it by the smallest possible speed, which is the smallest possible time, sorry, which is 2.65. What's that equal to? 53.5 divided by 2.65. That is equal to 20.188, which I'm going to round up to 20.19 to 2 decimal places. Okay, so I've got the lowest possible speed by taking the smallest distance and dividing by the biggest time, and for the upper bound I took the largest possible distance and I divided it by the smallest possible time. Okay, and that ended up with the upper and lower bounds for my speed. Question 16. The following kinematics formulas may be used in this question. So we've got v equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. Now it says we may need them, doesn't mean we need to use all three. Okay, I think we have to pick, don't we? So the initial velocity of a particle is 20 meters per second. The acceleration of the particle is minus 8 meters per second squared. And after t seconds, the particle has travelled 25 meters. Show that 4t squared minus 20t is equal to 25. Okay, so which of the equations is going to deliver me that? Which one has got t squared in it and t? It's going to be this one, isn't it? Oops. I think we're going to be using this one, aren't we? Okay, that's got the t squared in it, so I think that's the one that's going to give us that quadratic. Okay, so that's the one I'm going to sub into. So let's see what we've got. S equals ut plus half at squared. So subbing in what we know. What do we know? The initial velocity, that is u, isn't it? The initial velocity is 20. Now we call that one u. Okay, so that is going to go here, in here. Okay, and then the acceleration of the particle is -8. That is my A. So A acceleration, that goes in here. And after t seconds, the particle has traveled 25 meters. That is our distance, isn't it? Which in SUVAT formulas is denoted by S. So this is our S, okay? And that then needs to go here, okay? So then the only thing we don't know there is t, so that's why we end up with an equation in t down here then. So let's sub in what we know. So 25 is equal to u, which is 20 lots of t, plus a half times -8 times t squared. Okay, so let's just tidy that up a little bit. Now we've got everything on one side equal to 0. Okay, so let's just rearrange. So then just simplifying that a little bit, 25 equals 20t. Half of -8, that's -4t squared then, isn't it? Okay, and then bring in everything over to one side, so add in 4t squared and taking away 20t from both sides. I'm going to end up with 4t squared minus 20t plus 25 equals 0 as required. Okay, so that worked. And then solve 4t squared equals 20t plus 25 equals 0. So now we have to go on and solve it. Okay, so solving a quadratic equation. Can we factorize it first? That would be nice if we could, because then I won't have to use the formula. So 4t squared minus 20t plus 25. Okay, if we can factorize it, then we're going to have factor pairs of 25, aren't we? So what are the factor pairs of 25? So what are the factor pairs of 25? You've got 1 and 25, or you've got 5 and 5, haven't you? They're the only options you got there. Are any of those going to deliver me minus 20 in the middle? Well, maybe, because I remember I've got a 4 at the beginning as well, so it's not quite as simple as that as well, because we could have a 4t and a t, or we could have a 2t and a t, 2t and a 2t there, haven't we? So is there a way of putting over 5 and 5 or a 1 and a 25 in here and deliver me 20 in the middle? It's not going to work with 40 and t. I was just trying putting like 5 and 5 in here, or 25 and 1, and it doesn't work out. But I'm going to try instead 2t and 2t. So 2t and 2t, and see if that works instead. Yeah, actually that might work, mightn't it? If I put the 5 in and the 5, and then make them both negative, then that's going to give me the positive 25 at the end, when negative 5 times negative 5 is positive 25. And the negative 5 times 2t is going to be negative 10 twice, isn't it? So that does seem to work. I'm happy with that. So 2t minus 5 times 2t minus 5 is equal to 0. Should really do it this way around, I suppose. So that implies that that's equal to 0, which you can see is a square, isn't it? That's actually 2t minus 5 all squared equals 0. Okay. So then what are the solutions? It's a repeated root, isn't it? So there's only one solution here. That's going to be equal to 0 when 2t minus 5 is equal to 0. So that's going to give me 2t is 5, or t is equal to 5 over 2, or a half, isn't it? Or 2.5, sorry. So t equals 5 over 2. It's just a repeated root. Question C. Show that the particle is stationary when it has travelled 25 meters. Okay. Now again, we've got these 3 SUVAT formulas that we can pick from, but which one are we going to use? Okay. Well, let's just write down the 5 things. SUVAT. And think about which one we've got and which one we need to find. Okay, so S, that's the distance travelled. Well, that's given in the question. It's 25 meters. U is the starting velocity. That was given at the beginning of the question as 20 meters per second. And then v, that's the end velocity. That's what we're trying to find. We want to try and show that that's 0 actually, don't we? So it's stationary. And then a, we were given that in the original question. It's minus 8 meters per second. And t, not given in the question, not given in, in fact, we don't even need it, do we? We're not interested in time, so that's the one we don't need. So in terms of the SUVAT formulas, we don't need those two because they've got t in it. We're going to be using this one, v squared equals u squared plus 2as. So let's write the formula down. V squared equals u squared plus 2as. Sub in what we know. U is 20, so it's 20 squared plus 2 lots of a, which is minus 8, plus s, which we know is 25. So what's that then? Just double check that on the calculator. 20 squared plus 2 times negative 8 times 25. That's 0. So that's it then, isn't it? We can say that velocity is 0, which implies stationary. Okay. Question 16. A plane flies from London to Tokyo. The distance is 9,600 kilometers, correct to the nearest 100 kilometers. The plane travels at an average speed of 820 kilometers per hour, correct to the nearest 10 kilometers per hour. Calculate the shortest possible flight time of the plane. Give your answer in hours and minutes, correct to the nearest minute. You must show your working. Okay. So first things first, we need to consider the limits of accuracy for our two values that we are using in this calculation. So we got distance, and we know that distance is 9,600 to the nearest 100. Now if you imagine the scale that was going up in hundreds and you had 9,600 on it, then the next number up on that scale would be 9,700, and the one before it would be 9,500. And so the ones that round to 9,600 are the ones that are going to be halfway between or closer then, aren't they? That range of numbers is going to round to 9,600. So where does it change from rounding up to rounding down? Well, halfway between 9,500 and 9,600 is 9,550. So bigger than that's going to round up, smaller than that's going to be round down. And at the other end, you've got 9,650. So bigger than that, you're going to round up, smaller than that, you're going to round down. Okay, so they're my two limits for the distance. Now, the speed, that is 820 to the nearest 10 kilometers per hour. So again, if I imagine a scale, the next digit up on that scale, if I was going up in tens, would be 830, and the one previously would be 810. And so the numbers that rounded to 820 are going to be 815 and 825. They're my two limits for the speed. Okay, right, so calculate the shortest possible flight time. So this is a distance speed time problem, isn't it? So I'm going to draw my distance speed time triangle. So what is the distance, what is the speed, what is the time? Okay, now I want to know the time, don't I? So my calculation is for time, and time is equal to distance divided by speed. Now I want the shortest possible flight time. So which values are going to give me the smallest value of time? Well, if I want the smallest value of time, I'm going to need the smallest distance that we travel. It's going to be that one there, isn't it? The 9550. Because if I pick a bigger number, I'm going to end up with a bigger time. So the distance I'm going to use is the lower bound of my numbers there. It's going to be 9550 kilometers. And my speed, which speed am I going to pick? Well, if I want to get the smallest possible time, I want to be traveling at the fastest possible speed, don't I? Because the number you divide through by, the bigger the number you divide through by, the smaller your outcome is going to be. So I'm going to be using the upper bound of the speed, which is 825 kilometers per hour. And don't worry that 825 technically rounds up to 830, but 824 4.999999 rounds down, and that's pretty much the same value. Okay, so then I want to work out what my time is from those two values. So subbing in those limits into the calculation, so 9550 divided by 825, what's that then? That's going to be 9550 divided by 825. That comes out to be 11.575. I'm going to round it off to 11.6. No, I'm not, because I need to put it in minutes and seconds first. So I've got that display on my calculator, 11.5757. If I press the time key, it should rewrite it in hours and minutes and seconds. Now I make that, let's just write it down as a decimal first. That's roughly 11.58, which in hours, minutes and seconds, pressing the timey-wimey key, is coming out to be 11 hours, 34 minutes, and 32 seconds. So am I going to round that up or down then? So 32 seconds is more than half a minute, so I feel like I should round that up. So to the nearest minute, it's going to be 11 hours and 35 minutes. I'm going to round up. Okay, because 32 is beyond halfway from 1 to 60, isn't it? Okay, 11 hours 35. Question 17. Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles an hour for 1 hour and 36 minutes. He finds this information out about his car. Average speed for 65 miles per hour or less, miles traveled per gallon is 50. For more than 65 miles per hour, miles traveled per gallon equals 40. Use the information to show that his car uses less than 3 gallons of petrol for the drive. Okay, let's have a look at the first stage of the journey. He drives his first 9 miles in 9 minutes. That means he's doing 1 mile in 1 minute. And if he can do 1 mile in 1 minute, he can do 60 miles in 60 minutes. So his speed here is 60 miles per hour. Okay, so he's starting off with 60 miles per hour, which is less. This is 65 miles per hour or less, so he's going to be doing 50 miles per gallon for that section of the journey. Then he drives his car over 65, so he's going to be doing at the slightly less rate for the next 1 hour and 36 minutes. So let's work out what the amounts are then. So miles traveled per gallon, 50. So if you can do 50 miles per gallon, how much gallons is it going to take to drive for 9 miles? I think I'm going to set this up as a ratio actually. So let's write that down as a ratio. So miles to gallons. We know that I can drive 50 miles for 1 gallon for the first stage. So this is stage 1. So from that I could work out how many gallons I can do in 1 mile by dividing by 50, and then I can scale it up again. I'm using the unitary method here, aren't I? So going via 1, so divide by 50 and times by 9 will tell me how many gallons I need to do 9 miles. It's always going to be a kind of a decimal, isn't it? So if I take 1 and I divide it by 50 and then I times it by 9 as well, then I'm going to do, my 9 miles is going to consume 0.18 gallons. Okay, so that's the first stage of my journey. Now for the second stage of the journey, I'm going to do the same thing. I can now do, because he's going faster than 65 miles an hour for the next 1 hour and 36 minutes. What we don't know at the moment is how many miles he travelled. And well, that's what we need. We need to know how many miles he did in that 1 hour and 36 minutes. So if he's going 70 miles an hour for 1 hour and 36 minutes, how many miles is that then? So DST triangle, distance, speed, time. The distance is what I want to find. I know the speed. The speed was 70 miles per hour. And the time taken was 1 hour 36 minutes. Now, hours and minutes is not so nice, is it? We need to really convert that into a decimal, I think. So 1 hour and 36 minutes. 36, there is 60 minutes an hour, so that's 1 hour and 36 sixtieths. So that's 1 and 36 sixtieths. In other words, it is 60 plus 36, 96 sixtieths of an hour. Okay, and D is what I want to find. So covering up D in my triangle, D is equal to speed times time. So distance travelled equals speed 70 times time, 96 over 60. So 70 times 96 divided by 60 is 112. So he's done 112 miles. Okay, so now we can set our ratio up then. So again, miles to gallons is, well, we've done, or we can do 40 miles in 1 gallon. Okay, so again, going via 1, that's, and then up to 112 would mean dividing by 40 and times in by 112. So if I do it on that side, I've got to do it on this side as well. Divide by 40 times by 112. So taking 1, divide by 40 times 112, I get 2.8. Okay, so that means we used 0.18 gallons of fuel in stage 1, and we used 2.8 gallons in stage 2. So total petrol used equals 2.8 plus 0.18, which is 2.98. He has used less than 3 gallons. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.